Next on the agenda, trying to build up to be able to graph some of these polynomials. We did end behavior, so we're kind of working our way from the outside of the graph in towards the middle. The middle is going to be where there's sort of more action, more of this up and down stuff. So the next thing we're going to do is find any x-intercepts, which are sometimes referred to as the zeros. I think the book calls them the zeros of the function, the zeros of the polynomial. X-intercept, of course, is where the function crosses the x-axis. So that's our horizontal axis. If we just do a quick sketch of a random polynomial, right, we'd have x-intercepts here, here, and here. Right? All of these crossing points. There's one here at the origin. This is some sort of positive value. This is some sort of negative value. So we're trying to find these x-intercepts on our graph. So this is happening kind of by definition. It must be then where the y value is 0. So for us, what that's going to mean is to find an x-intercept, we're going to set the function itself equal to 0, and we're going to solve for the x. Because these are polynomials, what this means is we're going to be factoring naturally, right? So if we have a polynomial and we have it set equal to 0, that was part of what we did, sort of solving quadratic equations back in chapter 1, or sort of solving polynomial equations. So that involves a lot of factoring, setting everything equal to 0. That's kind of what we're starting with. So that's sort of one step down. Then sort of factor it out and solve for the x. So let's do a couple examples. We're going to do some stuff with these x-intercepts. There's a couple properties we need to talk about once we've found them. But for this video, we're just going to find them. We'll talk about what the kind of implications are afterwards. We're also going to step this up a little bit. So instead of just starting right with a quadratic, the stuff we want to graph is, in theory, like a little bit bigger than that. So I'm going to start us with a polynomial that's 4th degree. So x to the 4 minus 5x cubed plus 6x squared. So find the x-intercepts slash the zeros. That's our goal. So the setup here is set it equal to 0, factor, and solve for the x. Generally speaking, right, the higher the degree, the more potential sort of intercepts we're going to have, the more potential solutions to this equation we'll have. In this case, we're degree 4, right? 4 x's, so we could have as many as 4 x-intercepts. We'll see if that's as many as we actually end up with or not. Who knows? I don't want to spoil it. So first and foremost, let me just sort of rewrite this whole thing. So we've got x to the 4 minus 5x cubed plus 6x squared equals 0. Probably unnecessary, but whatever. The first thing we're going to do is look for and factor out a GCF from the whole thing. So if it's possible to factor out some sort of common term from everything, definitely do that. That's going to be something that definitely happens for us, right? As the degree gets higher, we just sort of are working with more x's, and so part of the trade-off for that in these problems, I think what you'll see semi-often is we'll potentially have some GCF stuff that we can pull out of everything. No numbers here, but our kind of minimum number of x's is x squared, so at the very least we can pull out an x squared from every single one of these terms, and then we'll be left with, on the inside, if we cut these all down by 2, right? X to the 4, if we take x squared out, leaves us with x squared. 5x cubed is going to leave us with minus 5x, plus 6x squared is going to leave us with plus 6. This whole thing, right, the whole idea is we're set equal to 0 the whole time, so we've got to keep that going. I'll do my best to keep writing that. So GCF out in front. Once we've done that, we're going to do our sort of just like regular factoring process with the leftovers. So we'll say factor the leftovers. So for us, right, that's going to be, this is kind of a equals 1, b equals minus 5, c equals 6. I'll do this factoring kind of off to the side, right? A times c, 1 times 6. We got to multiply to 6, positive 6. And then our b value is minus 5. So we've got to add to minus 5. So I'm running through this kind of quick. This is sort of back from our P5 factoring review. So if you haven't watched those or you need a refresher, definitely check those out. Without going through all the combinations, like what's going to work here, 1 and 6 could potentially get us to 5, but it would have to be a positive and a negative version to do that. That's not going to get us a positive 6. We need the signs to be in sync. So in this case, that must mean 2 and 3. 2 times 3 is 6. I need to hit negative 5 when I add, so it must be negative 2 times negative 3. Right, negative 2 plus negative 3 is minus 5. So negative 2 and negative 3 are going to be my pairs. This is a equals 1, so this is our special case where the first coefficient is 1, which means rather than necessarily go through the sort of full factoring process, pulling it apart, putting it back together, I'm going to sort of jump us right to just factoring via these two numbers. So, right, x minus 2 times x minus 3. Our GCF, right, our x squared is out in front. And then this whole thing, right, is still equal to 0. At this point, right, that's factored. That's about as factored as that's going to get. Right, we've sort of broken it down. There's not really a way to break it down further. You could write x squared as x times x. That seems a little bit redundant to me, at least for now. We'll kind of come back to that idea. So to solve this problem then, to solve for the x-intercepts, to actually find the values here, what we need to do is set each of these pieces individually equal to 0 and solve for the x. So we're going to get then this first term, right, x squared equals 0. The only way to square a number and get 0, that means that x itself must be 0. So that's going to be the first of our intercepts. The second one, right, so if this means x minus 2 equals 0, to solve for the x, if we added 2 to both sides, that must mean that x is positive 2. So that's going to be our second intercept. And then from this third piece, you can probably guess what's going to happen. Same kind of steps each time, right? The pattern here is pretty clear. X minus 3 equals 0, which means then if we add 3 to both sides, we're going to get x equals 3. That's the third intercept. So we have 3 x-intercepts. And so that happens at x equals 0 and 2 and 3. So that's 3 points where our function is going to hit the axis. We're going to talk again and build up a little bit more. In theory, there are sort of multiple ways when that could happen. But we'll build up and talk about that in the next video. I'd like to do one more example. We'll try to run through one maybe a little bit faster. Same kind of idea. Let's find our x-intercepts. Intercepts slash our zeros, right? So zeros are the function again because you're hitting y equals 0. Let's do g of x is 2x cubed minus 6x squared minus 2x plus 6. So this is a degree 3 polynomial, right? And it actually has 4 terms. So you could pull a GCF out of here. It would just be a number. Why don't we do that, I suppose? Let's actually be consistent. The idea, right, is we're going to set it equal to 0. We need to sort of factor and solve for x. We just don't really have a way to do this without factoring. So factoring is going to be key to all this. Obviously, there's not a common x term here, but we could do, right, 2 and 6, 2 and 6. I could, at the very least, factor a 2 out of everything. That's going to get me a slightly simplified polynomial, but every little bit helps, so that's good. If we have this, right, broken down in terms of 4 different terms, we can do our factoring by grouping with what's on the inside. So we're going to look GCFs across our sort of first 2 and last 2. This overall GCF, this positive 2, is just kind of along for the ride. Positive 2 is going to just hang out here on the outside. We'll leave it alone for now, and we'll just sort of take a note of that. X cubed and 3x squared, we can take x squared out. That's going to leave us on the inside with x minus 3. The second 2 don't have anything really in common, right? I mean, there's no x's there in common. There's no numbers in common. What that's going to mean to us is the best thing we can do as far as rewriting this is our GCF would be 1. It's sort of a trivial GCF, right? There isn't really anything we can factor out just to sort of fit the form. We're going to put the 1 there. And what I'm going to suggest is if we have this third term as negative, my suggestion, and I think what will typically be best, is to actually take the negative out in front also. So in some sense, what we're factoring out is a negative 1. So if I take a negative 1 out, that's going to leave me with just like a positive x here, and it's going to flip the sign on this 3 from plus 3 to minus 3. That's good, right? Because then that means x minus 3 and x minus 3 are both in sync, right? So I can pull that out there. I'm going to be left with then in front of that x squared minus 1. This 2 comes down, and then our whole thing is equal to 0. That's pretty factored. We can go one step further, however, and hopefully we'll notice one of our special cases. This x squared minus 1, this is our difference of squares. So the idea here, x squared minus 1, is really x minus 1 times x plus 1. So that's going to allow us to break this up into, so 2 out in front and then 3 individual parenthesized parts. You could solve it without doing that breakup. You would just need to get, in theory, 2 different solutions from this piece. So 2 times x minus 1 times x plus 1 times x minus 3. Totally factored. That's factored all the way down. As far as then finding the actual intercepts themselves, what's going to happen? We'll see if we can squeeze this in here on the bottom. So 2 out in front, 2 equals 0. No, there's no x's here, right? So as far as the constant 2, pulling that out gets us just a smaller polynomial to work with. It doesn't slow us down at all. We're going to have x equals 1. This is going to be x equals negative 1. And this is going to be x equals 3. So those are going to be our 3 intercepts.